All right, good morning and welcome back. Today we are going to be talking about trapezoids. So far this chapter we talked about polygons, then we talked specifically about quadrilaterals, and within those parallelograms. And parallelograms are when we have two sets of opposite sides that are parallel. Now a trapezoid, similar to that, but not quite the same. Notice here it says it's quadrilateral with exactly one pair of parallel sides. So not two, just one. And sometimes that might look like this. You see how the top and the bottom are parallel, so I could draw that. And then the sides there, the legs, they kind of go opposite ways there. Sometimes it might look instead more like this. Starts looking like a rectangle, but then that last side is slanted. Okay, and if that's the case, I'm going to put 2 here because they aren't necessarily the same as the first one, but okay, so those are our 2 different kind of general ways that a trapezoid might look. Now, generally a trapezoid, it just has one pair of parallel sides. There's a more specific name. This is an isosceles trapezoid, and that is when the legs of the trapezoid are congruent. Okay, just like an isosceles triangle, 2 sides that are the same. In an isosceles trapezoid, 2 are the same. That would be like this. So an isosceles trapezoid still has the one set of parallel sides. So the top here is parallel to the bottom. And then this side and the edge, those 2 are congruent to each other. And if this was 5, so is this. So we have a couple rules we know to be true about trapezoids, specifically isosceles trapezoids. And it says if a trapezoid is isosceles, then each pair of base angles are congruent. What I mean by that is D is congruent to C. Also, A, if I put 2 there, is congruent to B. Okay. Now our second one, it says if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So here we have 2 that are the same, D and C. We know without a doubt this is isosceles. That would also mean A and B are the same as each other. And finally, a trapezoid is isosceles if and only if its diagonals are congruent. So from A to C and from B to D, those will be the same. So with that logic, we look here, WXYZ is an isosceles trapezoid. It's also marked. Find the measure of angle X. So angle X right here. Those would be base angles, so that's also going to be 110. Okay, angle Y. You might not remember, but keep in mind, if these are parallel, if we have 2 parallel lines cut by a transversal, these would be called same side interior or consecutive interior. So X and Y would have to add up to 180. 180 minus that 110 gives us 70. And we could have the same situation on the other side, or we know that these are the same, so Z will also be 70. All right, we look here, letter B, it says ABCD is an isosceles trapezoid. We need to find these angles. So if this is 35 degrees, we know angle A is also 35 degrees. Now this one is an isosceles. It doesn't have the markings, so I'm going to put a mark there and there just to show. And once again, we'll take 180 minus that 35 to find what the other 2 will be. And we get 145. That goes both for B and for C. If you want to double check, there's 4 sides, so it should add to 360. 145 plus 35 gives us to 180. Plus 35 gives us to 215. Plus 145 gets us to 360. And we're good. All right, one other thing I want to talk about today with trapezoids is the mid-segment theorem. And anytime we have a trapezoid, there's a mid-segment, and this runs through the middle. It is parallel to each base. So BC here is a base, AD are a base. The bases are the two parallel sides. So it's also parallel to that. And then we know it is going to be 1/2 the sum of the lengths of the bases, also known as the average. Now let me explain all this. So let's look at this picture first. So BC and AD, those are congruent because parallel. Now, we don't know if this is isosceles or not. There's nothing that tells me this side is the same as this side. But I do know MN is the mid segment because you see from M to B and M to A is the same length. So that means that's in the middle. From N to C and N to D is the same length because there's 2 marks. So that's in the middle. So right here, if you wanted, you could add another marking because that is parallel to those other ones. Okay, and if we wanted to know from M to N, the distance from M to N is going to be equal to, if we add we sum up the bases, so BC plus AD, and then you see it's 1/2 of that. So we'll take BC plus AD and 1/2 of that, or divide that by 2. Okay, so got a couple of these to try. If we look here, it says find MN. So first, M, definitely in the middle. N is in the middle, so we know that's the mid segment. We have 10 and 16, so we can just add those together and divide by 2. 10 plus 16 is 26, divided by 2, so we will get MN to equal 13. Now, next one, same approach, except this time they have an X. It's the same thing though. We just add the top and the bottom together, the bases together. So 7 plus 14 gives us 21. Divide that by 2, and we will find X to be 10.5. Okay, now the last one we're doing today. On this last one, instead of asking us to find the mid segment, we are told the mid segment and one of the bases. We need to figure out what the other base is. So we know that X plus 15 divided by 2 equals the mid segment, and in our case the mid segment is 17. So to solve this, I can multiply both sides by 2. I'll be left with X plus 15 equals 34. Subtract that 15, you'll get X equals 19. So that goes right here. That hopefully makes sense. If we wanted to double check it, the distance, like on this one, 7 to 10.5, that's a distance of 3.5, or a difference. And then add another 3.5 on, that gets us to 14. It has to be halfway in between. Do you see how 13 is 3 away from 10? It's 3 away from 16. So in the same way, 17 is 2 away from 15. It's 2 away from 19. So we know we did it right. So go ahead, sign into It's Learning, get the assignment done. If you have any questions, please reach out. Hope you guys have a great day. Bye.